Okay, so this is a question paper from March 2022, question paper 1, variant 2, question 7. So it says show that this expression is identical to this, right? Okay, so what we have to do now is deal with the more complex looking one, which is this. Try and get it to look like that. All right, the first thing we have to do, right, would be to essentially get the common denominator. Let's obtain an expression that has a common denominator. And to do that, I'm just going to zoom in a bit. I'm going to do cos theta cos theta plus 2 sine theta, right? And then going to expand that. For the one on top, let's remove this. Okay. For this one, right? So this goes away. This cos sine theta gets cancelled out, and then we're left with this. So it's going to be cos theta plus 2 sine theta multiplied by sine theta plus 2 cos of theta. Okay, minus, and then for this one, this will fall away, but this will be there. So okay, and then from there we start to expand out, right? So we'll expand on the top. So then this becomes cos theta sine theta, which is this, right? Then we do that. Okay, it's going to be plus 2 cos squared theta. Then we do this one. This is plus 2 sine square theta. Okay, and then we do that one. This becomes this becomes 4. Okay, this becomes 4. Sine theta cos theta. Okay, then we move to the sine. I'm going to put this on in a bracket. This becomes cos. This becomes, go this way. Go that way. We go this way. And then we go that way. This becomes 4 sine theta cos theta. Okay, close the bracket there. Okay, like that, and that's our numerator. Okay, and then I'll just keep this for now. Cos theta minus 2 sine theta cos theta. Okay. Essentially, we are going to then have to do some cancelling out. Okay, so I think rather than writing this, okay, let me just write it again. Okay, so this is going to be zoom in, right? So this is cos theta sine theta plus 2 cos square theta plus 2 sine square theta. Yeah. And then this becomes plus 4 sine theta cos theta minus, remember the minus, cos theta minus times minus plus cos plus minus 4. Alright, now we can look out just do the denominator for now as well. It becomes cos squared theta plus 2 sine theta, then minus 2 sine theta, and then plus, no, sorry, minus 4 sine squared theta. Yeah, okay. So now we're left with 2 cos square theta, 2, in fact, I'm not going to write all of that out. Okay, you can just do the math together. Okay, we have this one, 2, that becomes 4. You have this one, and that one becomes 4 sine squared theta. Here, this cancels out, so we have cos squared theta minus 4 sine theta. Okay. Then from there we can remember that and why do I want sine? Because remember I want it in terms of cos because there's no sine here. Alright, cool. So we go back. 4 cos square theta plus 4, 1 minus sine. Sorry, this becomes, okay, this is cos square theta minus 4. Okay, this becomes 4 cos square plus 4 minus 4 cos theta. This becomes cos squared minus 4 plus 4. Right, and this cancels out, and then we left with 4, 5 cos minus 4, which is what we have on the top. Okay. All right. Now, for part, that was A. For part B, they say solve the equation of sine theta. So sine theta minus sine 4 degrees theta 180 degrees. Okay, and we already know that this is identical to 4. 5 cos squared theta minus 4 is equals to 5. Therefore, we can write it as that, and rather than doing this mess. Okay, so we can cross multiply or take this to that side, right? Essentially, what we're going to do is multiplying both by the denominator. Okay, then we get 4 is equals to 5 cos squared 4, right? And then from there that becomes 4, 25, 20, and then this becomes 24 because we took it to that side, and then 25 cos squared theta 5, and then we can say cos theta, right? Okay, and this can be, since it's a square, it's like a plus minus, right, of that. And then we can also say theta is equals to plus minus cos inverse of 25. Okay, then we get our answer. So we say cos inverse put in a calculator. Okay, 0.201 rads. Right. And then it's around that's around 11.5 degrees. And then for the second quadrant, right, they said between 0 and 180. So this is here, 11 degrees, and then we can have it happening another place, and that will be pi minus 0.201. Okay, and that gives around 2.94, and that's somewhere about 168, 168.5 degrees. Cool.